Hello students, now today we are going to start our next chapter, chemical bonding. This chapter is one of the most important chapter of chemistry as a whole, because without this chapter you cannot read or you can't understand organic chemistry, inorganic chemistry, organic chemistry as a whole, because this concept of chemical bonding are required to us almost in every chapter, directly or indirectly, maybe of any portion of chemistry. Moreover, if you think of your examination and entrance, from this chapter you at least get 2 to 3 questions per year in all entrance examinations. And this chapter basically is a bit long topic, because this chapter will cover different theories of bonding, and their different theories of bonding, their theories, merits and demerits, understanding of chemistry of the compounds from the structure of molecules. So in the given chapter we are dealing with most of the concepts which are required to us for study of the entire chemistry, especially inorganic chemistry. Without this chemical bonding you cannot think of, because inorganic chemistry will use the concept of chemical bonding almost in each logical or reasoning based question. And then we can take your organic chemistry also at many points is requiring chemical bonding concepts which are helpful to us for understanding the reactions or reaction mechanisms as well. And then for studying this chapter, chemical bonding, what we require, you should be clear in the concepts of, we can take your atomic structure, the shapes of molecule, the shapes of orbitals, electronic configuration of elements in terms of old system and new system as well, especially the shapes of orbitals, s, p, d orbital shapes, because in many points when we take the shapes of molecules in terms of orbital diagrams, we require that. And we require the concepts of periodic properties, which already we have discussed in the previous topic, periodic properties. Like we can take properties required as ionization enthalpy, atomic size radii, electron gain enthalpy, elements electronegativity. These all the properties also required here for understanding the chemical bonding concepts. If you are clear in chemical bonding, then later on is organic or inorganic portion chemistry you will be very comfortable. Otherwise you always have problem कि सर वो कैसे हो गया, कैसे करना था. तो anyway, chapter is very interesting, very logical reasonings are available at almost all the points, leaving 1 or 2 points where you have to just keep in mind some points. Rest can be explained with reasoning for all kind of points. Now before we move for the topics in the chapter chemical bonding, let us take an outline of syllabus, the topics that we are going to discuss in the given sequence. See, first we can take here introduction to chemical bonding by taking different types of bonds. Types of bonds. Organic bonding. See, we can have bonding, covalent bonding, ionic bonding. We can have then coordinate bonding or coordinate bonds, and we can have then metallic bonds. So in bonding we take bonds can be taken covalent bond, ionic bond, coordinate bonds and metallic bonds. That is bond taken. Then we take different theories in covalent bonding. Theories in covalent bonding. Like in covalent, actually you get question most commonly from covalent bonding, and in the given chapter chemical bonding, this topic covalent bonding will cover most of the time of the given chapter, because we are dealing here starting from we can take here Lewis octet theory, then you can take valence shell electron pair repulsion theory, then you can take valence bond theory, then you take concept of hybridization, and you take molecular orbital theory. Then other topics can be taken here. Your dipole moment, then you can take Fallon's rules, then you can take hydrogen bonding and other weak forces. You can call them van der Waals forces. Other forces of interactions which are commonly called van der Waals interaction forces. So we have dipole moment, Fallon's rules, hydrogen bonding, van der Waals interaction forces. In ionic bonding, we will discuss this topic separately. Metallic bonding and ionic bonding sequence we will keep like this one here. First we will take just introduction of bonds, and then we will discuss in detail first different theories of covalent bonding, and then we will come back on again ionic bonding, property of ionic compounds, then you can take coordinate bonds, and then metallic bonds. That will be sequence after covering this covalent bonding theories. And last you can take here this topic will be covered in between as per the required sequence. Say in different books you may have different sequences, but I will try to take sequence in which you can get maximum benefit. You can understand this chemical bonding in a simplified manner, because we teach complex things in the beginning. सर को बहुत नॉलेज है, लेकिन आपको समझाना है मुझे इन सिंप्लीफाइड मैनर. तो पहले आपको समझने के लिए क्या सीक्वेंस बेटर होगा, आपको चैप्टर में वैसे पढ़ाऊंगा उसको, ठीक है. तो उसमें हम पहले पढ़ाएंगे डिफरेंट थ्योरी ऑफ कोवलेंट बॉन्डिंग, ठीक है. उसके पहले जस्ट वी टेक स्मॉल इंट्रोडक्शन अबाउट द टाइप्स ऑफ बॉन्ड्स एंड व्हाई बॉन्डिंग इज रिक्वायर्ड, डेफिनेशन ऑफ केमिकल बॉन्ड. ऑल दिस विल बी डिस्कस इन द बिगिनिंग. ओके, नाउ टू स्टार्ट हियर, let us first see, we have some questions whose answers we require. In the given chapter, we seek the answers of the following questions. We have some questions before we start the chemical bonding or definition of chemical bonding. There are some questions whose answers can be given by different concepts of the chemical bonding. So what are the first? We can take some questions are there whose answers we require. Like first question, why do atoms of same element or different elements combine from compounds, and they form compounds in normally a fixed ratios? Like you can take here in formation of molecules, suppose the hydrogen atom can combine with other hydrogen atom to form H2 molecule, but that does not form H3 molecule. So why they form H2 molecule, why not form H3 molecules? So like we can take why do some atoms of same element or different element combined from compounds? So why there is need of compound formation? First question. Second, why do some atom combine while others do not combine? We can take hydrogen atom combined from H2 molecules, but helium atom do not combine to form Ha2 molecules. What is the reason for this? Other question can be taken like, which are the different kind of forces? Which are different kind of forces which can hold together atoms or atoms in a molecule or in different arrangements? So which can take what are different kind of forces which hold together atoms and molecules in different arrangement? Next question can be taken, why do particular shape are adopted by the molecules? Like we can take here example, CO2 molecule is linear. CO2 molecule is linear, but water molecule become bent or angular shape. If you think na, we have one carbon, two atom oxygen, so as a whole we have three atoms. We also have three atoms here, But why the shape of CO2 molecule is linear, water molecule is bent, ammonia molecule is pyramidal shape, whereas if it is taken BF3 molecule is trigonal planar shape. So why do molecules are having different shapes even when they can contain same number of atoms in the molecule? So about that we will discuss. Then we can have why a particular arrangement of ions in ionic compounds is preferred. About this ionic compound structures, especially we can take structure of ionic solids, because ionic compounds are mostly solids. So about their structures in details will be given in chapter solid state. The ions can occupy different kind of lattices in space. Details are given in chapter solid state, but we will take some basic ideas here also. So there are some basic points whose answers can be given by the chapter chemical bonding. So the chapter chemical bonding, to start here, first we can take definition of a covalent, definition of a bond. What is a bond or chemical bond? Now first can be taken chemical bond. What is definition of chemical bond? See, chemical bond can be taken as the force of attraction. This can be taken, it is a force of attraction, force of attraction among the constituents, which can be your atoms or ions, because in covalent compound we will have atoms, in ionic compound we can have ions. It is the force of attraction among the constituents which hold them together, The force of attraction, it can be taken forces of attractions, because when you take, it is a big definition in which we are including ionic compounds, ionic bonds, covalent bonds. In fact, all kind of bonds are included here in this definition. So there are the force of attractions among the constituent particles, which can be atoms or ions, which will hold them together, which can hold together atoms. You can take simply covalent bond if they have covalent bonding. So it is definition part, force of attractions among the constituent particles, which can be atoms or ions, which hold them together, is called as a covalent bond. Now it's called a chemical bond. Now chemical bond can be taken of different categories. We can have covalent bonding, we can have ionic bonding, or we can have coordinate bonding, or we can have metallic bond. So let us take, you have some basic idea about the covalent bonding or ionic bonding. Normally the atoms will combine to attain stability. If you know the atoms, just to compare, we have discussed in the previous chapter periodic properties, periodic table, that we have element of group 18 which are called as noble gases, or also called inert gases. They do not form compounds at all, leaving some compounds are formed of xenon or 1,2 compound of krypton, but otherwise remaining noble gases do not form compounds. Now why they do not form compounds? The common reason was that they have highly stable electronic configurations. They have highly stable electronic configurations in which the atoms have complete orbitals, complete shells, so that they don't require any extra electrons, or they cannot even give electrons for either case. So what happen? Elements which are noble gases or also called inert gases are not reactive. In general they cannot react. Xenon can form some compounds, that too under drastic conditions with strong oxidizing elements like fluorine or oxygen, but otherwise no other noble gas can react. Krypton can form 1,2 compound as well, known here, but not very stable type. So other elements are highly reactive. Some elements are highly reactive, some are less reactive. So that depends, but they can form compounds. Compounds can be taken, formation of compounds can be taken by two methods, either by electron sharing or by electron transfer. If you just take here in covalent bonding, we can have bonds taken here. Covalent bond, it is formed by sharing of electrons. Formed by sharing of electrons. Atoms can share 1, 2 or more electrons because atoms are having either incomplete octet or they can have they will have unstable configurations. So when the elements, they can donate electrons or they can gain electrons, but by electron sharing only. So it can be taken first, can be taken covalent bonds. It is formed by sharing of electrons. Second part can be called as ionic bond. Ionic bond is formed by electron transfer. Electron transfer. Okay, if it is taken in ionic bond, one atom lose electron, second atom gain electron, they form ions. Again in ion formation, the ions try to have noble gas configuration. Ions try to have noble gas configuration. When the ions acquire noble gas core, noble gas configurations, and then they can interact with each other by electrostatic attraction force. So ionic compounds are having ions existing together, having in them strong electrostatic attraction forces, which make ionic compounds solids. If you take covalent compounds or molecules having covalent bonds, leaving some exceptions, giant molecules or otherwise, they are normally liquids or gases or soft solids. But ionic compounds are solids having high melting points, high boiling points because of strong electrostatic attraction forces which are existing among the ions. तो यहाँ पे क्या हुआ, atom try to have complete octet by electron sharing. Here atom try to have complete octet by electron transfer. Example taken like NaCl, well-known compound NaCl, where sodium have outermost shell 1 electron lost to form sodium ion. Cl atom require 1 electron to have noble gas core from Cl negative ion, and then sodium plus and Cl negative ion are having in them electrostatic attraction force which hold together NaCl. Next compound bond can be taken. Coordinate bond. In coordinate bond, what happens? It is basically mixture of two ionic or covalent bond. Here what happens? One atom give electron, means it is a covalent bond. Nature wise it is covalent bond. It is a covalent bond in which both electrons comes from same atom. Same atom. Means if I write suppose here A have got 2 electrons, B have no electron to form bonds. So what happens? Electron pair of A can be given to B, and then they form AB. A positive charge, B minus charge. This electron pair now become property of both the atoms. This electron pair become property of both the atoms A, B. A plus B minus. That is taken coordinate bond, and one is called metallic bond. In metallic bond what happens? They are existing in metals. About them we will discuss in detail. In metals what happens? They cannot form covalent bond or ionic bonds because we are having all the atoms of same elements, and moreover each atom of metal is having surrounding to them at least 6 or 8 or 12 other atoms in contact. So they cannot form definitely 6, 8 or 12 covalent bonds. Or in atoms of same elements, electron transfer is not allowed, not possible. They do not form even ionic compounds, ionic bonds. Or we can take this kind of bond again, not possible because all the atoms are same element. In formation of coordinate bond, what is the requirement? It is a covalent bond in which both electrons come from same atom. One atom give electron pair to both B, and then they have bond formation, covalent bond formation as A plus B minus. A give electrons over plus 1 charge, B will gain electrons so will have negative 1 formal charge. It is called formal charges that can develop on the atoms of B. Now you can think this in two steps. First can be taken here A have 2 electron and B suppose without electron. So what happen? First 1 electron given to B. So what happen? A and B. Now A will lose 1 electron so will have plus 1 charge, and B will gain 1 electron so have negative 1 formal charge, and then they will interact. This electron now will be used in the covalent bond formation. So it can be thought to be like combination of ionic plus covalent bond. In the covalent bond both electrons come from same atom. You can think this way in two steps कि A एटम और B एटम था, A एटम ने एक इलेक्ट्रॉन लॉस किया, इस पर आएगा प्लस चार्ज, B ने एक इलेक्ट्रॉन गेन किया, इस पर आएगा नेगेटिव चार्ज, दो इलेक्ट्रॉन्स हैं, तो क्या बनेगा? एक सिंगल कोवलेंट बॉन्ड. अब उस बॉन्ड के दोनों इलेक्ट्रॉन कहां से आ रहे हैं? उस बॉन्ड में दो इलेक्ट्रॉन्स हैं, वो कहां से आएंगे? एक ही एटम से. तो सच काइंड ऑफ बॉन्ड इज कॉल्ड एज कोऑर्डिनेट बॉन्ड. इट इज बाय नेचर कोवलेंट बॉन्ड. कब होता है? when one atom have lone pair and one atom have incomplete octet, or one atom is electron deficient, or it have vacant orbitals. तो about that we will discuss in slightly more details. लास्ट आपका मेटेलिक बॉन्डिंग. तो मेटेलिक बॉन्ड क्या होता है इन मेटल्स, उसके बारे में आपको सेपरेट पढ़ाएंगे. अब आते हैं पहला पॉइंट है इन डिफरेंट थ्योरीज ऑफ केमिकल बॉन्डिंग. फर्स्ट वी कैन टेक कोवलेंट बॉन्ड्स थ्योरीज. In covalent bonding, the first theory we can take by Lewis. He gave. We have two scientists, Causel and Lewis, which gave the theory, which is normally called as Lewis octet theory, which try to explain the nature of bonding in terms of complete octet. So let us come next point. Now, in chemical bond formation, we have discussed till now that bonds can form of four categories. One taken by electron sharing, one taken electron transfer. When electron sharing is there, they will form covalent bonds. When we have electron transfer, then we can have ionic bonds. If one atom lose electron from positive ions, second atom gain electron from negative ions. Then ions have in them electrostatic attraction force. Next can be taken coordinate bonds, in which they form single covalent bond. Atom forms single covalent bond where one electron pair come from single atom. And then you can take metallic bonds. Metallic bonds we will discuss separately after completing our molecular orbital theory, because in metallic bonding we have one theory called band theory. That band theory is based on molecular orbital theory. So anyway, in covalent bonding theories, first theory can be taken Lewis octet theory. Basically, Lewis has seen, or we have two scientists were there, Lewis and Causel. In 1916, they tried to first give this theory for bonding or chemical bonding, that they just taken halogens, noble gases and alkali metals, group 1 elements. What they found that group 1 elements can lose electron from noble gas configuration, or group halogen family can gain 1 electron from noble gas configurations. So that similarity they have just compared inert gases were taken as reference. Inert gases or noble gases do not react. Why they do not react? Because they have stable configuration. Like helium have 2 electrons, remaining element have 8 electrons in the outermost shell. So they have taken 8 was the number which could provide stability, or in helium case 2 electrons were there. So when the elements can have stable configuration, just leaving helium remaining, all the noble gases are having 8 electrons. On same concept, Lewis proposed that the element should share electrons. In covalent bonding or in ionic bonding, they can transfer electrons. Electron exchange can take place, in which the atom try to have a stable configuration, in which we can have 8 electrons in the outermost shell, either by electron sharing or electron transfer. Now in Lewis octet theory, we are focusing on completing octet by electron sharing. So in writing this Lewis octet theory, we can just take first Lewis symbols. Lewis symbols क्या होते हैं? For elements, we just write one electron as one dot. We write electron as dot. If I take elements of second period, we will have first lithium, then beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. How for these elements we write the Lewis symbols? We write one electron as one dot. In beryllium 2 electrons as 2 dots, boron 3 electrons as 3 dots, Cf 4 electrons as 4 dots, nitrogen have 5 electrons, so we write 2 electrons here and 3 dots, single. In oxygen, in fluorine 7 electrons and neon 8 electrons. So neon will not form compound, but remaining elements can share one or more electrons. This electron dot structure, they can tell the valency of the elements. If you take valency of the elements, we can write here from this Lewis dot structures what valency you can write here from the Lewis symbols, that in lithium you have single electron, so a single electron, this from single bond, it has valency 1. Beryllium have got 2 electrons, so we'll have 2 valency. Means what is valency means? The tendency of forming the covalent bonds by the elements. Boron can form 3 bonds having 3 electrons, C can form 4 bonds using 4 electrons, and nitrogen form 3 bonds using 3 electrons which are unpaired. And again we take oxygen form 2 bonds to have complete octet. Fluorine can have 1 and neon have 0. So you can say for the elements in valency there is one pattern, that valency increase up to 4, 1, 2, 3, 4, again decrease 4, 3, 2, 1. So valency first increase up to 4 and then decrease from 4 to again 1. And noble gases, inert gases, they are inert because they have complete octet, they have stable configurations. So when we have stable configurations of 8, they are stabilized, but remaining are less stable, and these elements, they will try to share 1, 2, 3, 4 electrons or again 3 electrons from other atoms so that they can have complete octet. So electron sharing capacity is given by the valency. Now, using these symbols, we write the structures which is called as Lewis dot structures. Like if I write in different elements, if I take some examples, how we write this Lewis dot structures. As per Lewis octet theory, it is giving too much stress on the completion of octet. It says that during the electron sharing, an atom can share 1, 2 or more electrons so that all the atom can have complete octet. So that all the atoms can have complete octet. This theory puts stress on the completion of octet by the atoms. Like if I take example chlorine or fluorine, anyone you can take here. In chlorine, in the outermost shell, it have got how many electrons? 7. So that's 7 electrons of outermost shell. Second chlorine. Now we have each chlorine atom is requiring 1 electron more for completing its octet. Each atom chlorine require 1 more electron to complete the octet. So what this says? It says that 1 electron pair. This one bonding. This two electron they share to form 1 bond pair. So this can be called as Lewis dot structures, which can be written this way also. In these 2 electron form bonds. These 2 electrons are forming bonds here, which are now shared between 2 atoms and remaining non-bonding electrons. These electrons which are non-bonding, they will form lone pairs. They are called lone pairs. Unpaired or unshared electrons, The unshared electrons form lone pairs. They are the shared electrons. This shared electrons, they will form bond pair. The shared electrons between two chlorine atoms, they will form bond pair. So in atoms or molecules, we can take molecules, we can have electrons in two categories. Some electrons are forming bonds which are called as bond pairs, or they are shared electron pair. It is called shared electron pair or bond pair. And this is taken lone pair, the non-bonding electrons, they are called this is formed by non-bonding electrons. The non-bonding electrons will form lone pair. So electrons can be taken two categories if we take in brief in molecules, lone pair and bond pair. Lone pair means the electrons which are remaining non-bonding, they will give rise to lone pair, and the other electrons which are forming bonds, they are giving bond pairs or shared electron pair. Unshared electron pair will form lone pairs. That is what we can take in Lewis dot structures or Lewis symbols. Writing the electron structures, electronic structures, it helps in getting rough idea that atoms can form how many bonds. Now it is this case here. If I take for example taken HCl molecule, in also HCl, chlorine has 7 electrons, hydrogen has 1 electron. So in this case what happens? Hydrogen will try to have complete duplet, noble gas configuration, and chlorine will share 1 electron. So they will form single covalent bond HCl. So this kind of structures which is drawn by writing the electrons and bonds between atoms or without the bonds, we can write here. These are called as Lewis structures or Lewis dot structures. Electron we represent by the dots, so it is called as Lewis dot structures. This structure is called as Lewis dot structures. Now if you draw this kind of Lewis dot structures, it is simple, but suppose we have bit complicated structures, then how to write?